We're going to look strictly at the hard physics, what modern physics, quantum mechanics, and thermodynamics actually have to say about the very fabric of our reality. Are we living in a tangible physical universe or an incredibly complex computational simulation?
You know, you've probably heard this famous quote from Elon Musk back at the 2016 Code Conference. This idea essentially echoes British philosopher Nick Bostrom, who in 2003 brought us the modern version of the simulation hypothesis. Bostrom basically argued that there's a pretty high likelihood advanced future civilizations would run sophisticated ancestor simulations. And if they have the juice, the computing power to run millions of these things, well, the statistical odds say we're probably inside one of those simulated realities, not the original creators.
To really wrap our heads around this, we first need to define a core concept: base reality. This is the actual physical ground zero. It's the ultimate reality where the theoretical, highly advanced computer running our universe would actually physically sit. If the simulation hypothesis holds up, base reality is literally the only place where the true laws of nature apply, totally unsimulated by a machine.
But look, moving past the science fiction, the pop culture matrix references, and the philosophical what-ifs, the absolutely crucial point we're investigating today is whether actual, measurable physics can prove this hypothesis. I mean, if we really are trapped inside a computer, surely the programming has to leave some kind of trace, right? Are there hard limits to the processing power of our universe?
Searching for cosmic pixels. So let's start our scientific detective story by looking for the pixels of our universe. Think about it. Just like a digital photo is made of tiny little squares when you zoom all the way in, physicists are actually hunting for the minimum building blocks of space itself. People like Silas R. Bean are seriously evaluating if our universe is built on a discrete numerical grid. In a 2012 paper, his team applied a method called lattice cosmology. They looked at how we currently simulate the motion of microscopic particles on supercomputers, and they just asked, what if our entire universe is already running on a lattice grid exactly like this?
And what they found is a massive contrast. On the macroscopic scale, what we see with our telescopes, space looks perfectly continuous and incredibly smooth. But if we're in a simulation, Bean's calculations suggest the microscopic pixels of space would have a lattice spacing of less than 10 to the minus 12 femtometers. That is an unimaginably small scale. We're talking basically 1/1000th the size of a single electron.
So how in the world would we actually see these pixels? Well, if space is a rigid grid, it would suffer from something called rotational symmetry breaking. Think about moving diagonally across a checkerboard. It's fundamentally a different distance and path than moving straight across. Researchers suggest that ultra-high-energy cosmic rays hitting the cosmic microwave background, a threshold we call the GZK cutoff, might actually reveal this. They would show jagged directional biases. Essentially, by tracking the absolute highest energy particles in the cosmos, we might literally bump into the invisible edges of the universe's pixels.